As you know, we already finished theory part of matrix. Now we'll move on to solving some problem regarding matrix. Okay. So we'll go with the simpler one, then slowly we'll move into beta forward. So the first one is to find, you have to prove it, that AB whole transpose is equal to, as you know, this B transpose cross A transpose. The orientation has to be changed in that, when you come to the right hand side. So the matrix is given, two matrices are given. A is given as 2, 4, 3, 2, and B is given 1, 3, -2, 5. So you can see these are all, both are square matrix of order 2 cross 2. So then we'll start with left hand side. Straight away you have to do multiplication of A and B first, then we'll take transpose. So first part of that, this is the first step. You can write first step, you have to do multiplication. So what you will do, 2, 4, 3, 2, 2, 4, 3, 2 cross 1, 3 -2, 5. Now you multiply this. What will do, row column 2 into 2, 2 into 1, 2, 4 into 2, -2, -8, 2 into 3, 6, 4 into 5, that is equal to 20. Then come second row, 3 into 1, 3, 2 into -2, -4, 3 into 3, 9, and plus 10. So this will the end of your multiplication. So if you reduce it, this is -6, 26, -1, and 19. This is the ultimate. So you can write it there, replacing this all. So your ultimate matrix is -6, 26, -1, and 19. So now what you have to do, the second step will be AB transpose. Okay, so transpose is nothing, row will convert to column only. So -6, 26 will come here, -1 will go there. So that means only the cross transaction between this. If it is a 2 cross 2, this is very easy to. For 3 cross 3, you have to take care of rows into column and all that. Be careful when you look transposing that. Okay, sometimes the digits are not in correct orientation and that is wrong. Okay, so you have to be very cautious when you are doing such thing, because matrix is very much need your concentration also. This is very much related to your test of concentration. More you concentrate, more you rapidly you can do, and more correctly you can do. Okay, so this is the case. Now come to right hand side. Right hand side will be, fine, it can be done directly. B transpose will be 1, 1, 3, -2, 5, and A transpose will be how much? If I do it, 3, 2. Okay, so this will be the case. Now we have to find B transpose, A transpose. So what is that? B transpose will be 1, -2, 3, 5, and A transpose will be 2, 3, 4, 2. Okay, now do it. 1 into 2, 2, 2 into 4, -8, 1 into 3, 3, -2, -4, 3 into 6, 3 into 2, 6, into plus 20, 3 into 3, 9, plus 10. So what is that? Ultimately you will find -6, -1, 26, 19. Now you see this is matching with the AB transpose. Okay, so you can say from this that AB transpose is equal to, hence proved, hence you can write, hence proved that AB transpose is equal to B transpose A transpose. But you remember, this only possible for square matrix. Okay, this formula or this property is valid for square matrix. Okay, so now we move to the next problem. Next problem. This problem I am doing from the NCERT book only, so that it will be easier you to understand. Now the next we will find summation and subtraction of two matrices. You have to find A plus B and A minus B. You have to find. So matrices are A is equal to 4 root 5. I am going very easy. Anybody can do once. This is just for revising your theory part. So I am just moving with the simpler one so that you can easily recapitulate your theory and you can do it. Later I will move to some tough problem, and that time your concentration is needed. You need not to go back to your theory to understand that. So that's why I am starting with a simpler one so that it will be a revision for you. Okay. So now I will go with both the things together because it's very easy. Now how will I do that? A plus minus means if in case I am adding, so everything will be added when I am doing subtraction. So you can do separately also, but it is a very simple problem. So I am doing. So what you have to do? Respective term you have to deduct. So this is first column first row, this is first column first row. So similarly this, now if I do, so I am putting all two signs together because I am doing simultaneously. When you will do it separately. A plus B will make it once and A minus B will make it successively. Okay. So this root 5 position is same, so this will become 0 whether you will do plus or no. You have to do it either or else it will be confusing. Let me take one by one because this may confuse you. Okay, so I will not go to that. So 4 plus root 3 first term, 5 plus, so 2 root 5 will be there when you will do plus. 7 plus 14.3. Okay. Then after this plus this will be 0. The matrix order will be same because we are doing plus or minus whatever you do. 0 plus 1/3 will be 1/3. 0.5, 0.25 means 0.75, isn't it? So either you convert into fraction or digit. This is up to you. But for the case of solving this problem, either you have to convert in decimal or matrix so that it will be easy, and that you can do easily because 1/4 is 0.25, 0.5, that will be 0.7. So this will be the answer for you. And if you do A minus B, something will change there because some of the cases the terms are same. So this is 4 minus root 3, this minus and this root 5, this will be 0. Then 7, now we are doing A minus B, so 7 minus 7.3, this will be negative sign will come and remaining 0.03. This minus 2 will come, 0 minus, this will added with minus sign only. This minus this means you are subtracting 0.5, 0.25, so that means ultimately it will become 0.25. So this will be your answer. Okay, this is very easy to go. Okay, so next problem. For simpler problem, I am moving fast. There is nothing to explain much, so I am not saying much in that problem to explain. The third problem, see what comes next. Okay, example. Now you have to find for three matrices. You have to find A plus B plus C. Means consecutively add, but you can do it in once if A, B, C are matrices. What are that? Or are given A, B, C. These are given First A is given as this is a relation which is trigonometric. So there are some predetermined relations or pre-proved relation, you can say. Some relations is already being established between these ratios. These are trigonometric ratios. They are having their own relation among themselves. So those can be used. So I haven't covered this subject yet, but I will shortly do. Okay. By that time I will say the formulas for those. Okay. So C is equal to, this is only numerical relation is given. So these are the three matrices given. Now we have to find A plus B plus C. So now in this case, you need not to do consecutively. You can do it at once. Okay, A plus B plus C, because rule is same. A plus B plus C, when you will do plus or anything combination of plus to minus, according you have to choose the sign when you add or subtract the respective position of the element. Okay, so now A plus B plus C, that means all the elements of similar position to be added. If it is in case there is a minus 1 minus C, let's say A plus B minus C, so in this case for A and B it will be added with the plus sign, and C it will be added with the minus sign there. So this is the only difference, because if it let's say A plus B minus C, so what we can do, this we can convert into this way. So once you will convert C to minus C, so this will ease your problem and you will go with the addition. Okay, so now here this is only plus, so sine square theta plus cos square theta, and for this is equal to 0. Second term is 1 plus 0, and this is minus 1, plus minus 1 means minus 1. Again this is cot square theta minus cosec square theta, plus means minus 1, and here 0 plus 1 plus 0. So this is the result. So now sine square theta plus cos square theta, this ratio value is 1. I will let you know when I will cover this subject in trigonometric ratio. So but you know it right now. This sine square plus cos square is equal to 1. So 1 plus 0 means 1. This everything is 0 plus and minus will be cancelled, so this will be 0. Cot square minus cosec square, this also become 1. So if it is 1 minus 1, that becomes 0, and here it is 1. Now you can see this is a identity matrix. Identity matrix of order 2 cross 2. Okay, so you need not to write it, but for understanding or revising, or you just keep on thinking what you are getting, what is relevant, what is related to that. You just keep it in your mind, so that everything will be revised all together at a time. Okay, so this is the third sum. Now we'll move on to the fourth sum. The fourth sum is you have to find 3b. There are three matrices 3b, 4c, and minus d. So I am writing the matrices what is given here. So B is given as B 2 3 0 1 minus 1 5. C is given as minus 1 minus 2 3 minus 1 0 2, and D is given as 0 4. This one is minus how much? Minus 1, minus 1, 5, 6, minus 5. So these are given. Now we will go at a time. Now we will not waste to find 3b, 4c, because these are all scalars. Scalars are adjusted in the matrix when it is multiplied with all the elements. Will multiply with all the elements, and accordingly the thing will change. So I will write it down directly. I will find 4c minus d. So come with me and just follow. 3 will be multiplied with all the elements, so this will be 6. Okay, now 6 with the 4c. 4c means c is this 4 minus 4. Okay, minus 4 will be added because we are doing add, then minus of d. Minus of d here is 0, so nothing. So d minus 0 I am writing for the sake of writing. Okay, so now we'll bring the second, because this computation 3 and 4 with the b and c will happen to all the elements, so you can do it once even. Okay, so for the second term, this will be the second term. 3 into b, 3 is 9, so 9 you can write here. For 4c, this is so minus 8, and d is equal to minus, so that means equal to plus 1. Understand? And let me take smaller places. So first one is 3 into 2, 6. Second was 4 into 1 minus 4, and this is minus 1 minus 0. Second term 3 into b, 3 into 3, 9. 4 into c means minus 8, and minus 1 is plus 1. Third, 3 into b, 0. 4 into 3 means 12, and minus, sorry, there is equal to minus 4 will come, and this is equal to minus 1 means plus 1. This is last time. This is 3 into 1, 3. 4 into minus 1, minus 4. Minus d means minus 5. Okay, 3 into minus 3. 4 into 0 plus 0, minus 6. 3 into 5, 15. 4 into 2, 8. Minus 15 means plus 5. Now you just cross check it once if it is done. 3 into 2, 6. 4 into minus 1, minus 0. 3 into 3, 4 into 2, and minus 4. 3 into 0, 4 into 3, minus plus. 3 into 1, 4 into minus 1, minus 5. 3 into minus 1, 4 into 0, minus 6. 3 into 5, 4 into 2, minus. So this is completed. Now this result will be 2 minus 5, 12, 9 minus 6. This is minus 9. This is 23, 28. So this will be the ultimate matrix. Understood? Move to the next problem, number 5. Now you have to simplify. It is written sec theta, tan theta, sec theta close minus tan theta, sec theta, tan theta. Okay, so this is also will be solved depending on the trigonometric ratios. There is a specific ratio. So before than that, we have to multiply. So this will become sec square theta, sec theta tan theta, sec theta tan theta. This will be sec theta tan theta again. This is sec square theta. Now minus this tan will be multiplied there, tan square theta, tan theta, sec theta, tan theta, and tan square theta. Okay. Now this can be multiplied in any orientation. I am writing tan theta, you can write sec theta, tan. That doesn't mean anything different. That is same. So now you have to deduct. So this will become sec square theta minus tan square theta. Sec theta tan theta, sec theta tan theta 0. Sec theta tan theta is also 0. Sec square theta minus tan square theta. Now this in trigonometric is equal to 1. 1 0 0 1. So this again a identity matrix, you can see. Okay. This is also identity. So these relations will come across when we teach this. But right now you need to know this is equal to 1. Cos square theta plus sin square theta is equal to 1. Cot square theta minus cos square theta is equal to 1, and they are related to each other by some relation. So those who will learn when we will come across the trigonometric ratios. Okay. So we will solve one more problem and we will end this session. This will be sixth problem. Sixth problem. Okay. If A is given as 0 C B C 0 A B A 0, then find A square. You have to find A square. Okay. So A square means you are multiplying A into A, but there you need not to be worried about the orientation because both are similar matrix. So you need not to be worried. So what you have to do, A into A you have to do. So you have to write one after one in the same manner because both the matrices are same. Now you have to multiply 0 C B C 0 A B A 0. So whatever the problem I am solving from the example given, not from the text that is given for solve. So there is always a very essential for student, whenever you pass see or refer any book, you see that each and every word of the subject, and you also have to see the problem that is being there as a solved problem, examples. So these are very much needed. Sometimes students skip those problems and go to the test directly or the exercise part directly. So the problems, whatever is given in the exercises, given as an example, are very you can say theoretically and mindfully been chosen and given as an example. So you don't skip it. You try to understand, solve it for yourself once after seeing the problem. Close the book and solve it for yourself by your own. So then it will be very easy the learning of the subject, and you can solve those exercises very easily. This is very much recommended. If you ask me personally, I always prefer students to see the problem that is given as in solved problems. Okay, so this I am taking from the solved problem. So A into, you know the rule, so 0 C square plus B square, the first term, then 0 C into 0 plus 0 B into A plus AB. Okay, then third term 0 into B 0 C into A AC B into 0 0. second C into 0 0, 0 into C 0, A into B, AB. The second term, this second term, C into C square, 0 into 0 0, A into A square. Okay, then C into B, BC plus 0 plus 0. Then B into 0 plus AC plus 0. AC into 0. B into C, BC, A into 0 0, A into 0 0. Okay, B into B square plus A square plus 0. So ultimately a matrix will become, if I write it here, so this is B square plus C square, AB, AC, AB, A square plus C square, or you can write it in other form, C square plus A square to make it cyclic, BC, AC, BC, AC, BC, and A square plus B square. Now you can also keep it in a means in a manner when you do some square of any matrix, how the terms will behave. You can see the first two terms, it will come B square plus C square plus AB and AC, means A is common, which is not there, which is in the other part of the matrix. So AB will be there and AC will be there. Okay, how the things will change? A is multiplied with B, the last term, and placed here, multiplied with C and placed here, and this is again in cyclic order. You remember B square will come first plus C square plus the other terms with AB first and then C. So now in this case, if you follow the same thing, the term will come in the middle where 0 is coming, square part will come in 0. So the cyclically this will become C square, because C and A is the C square plus A square. Now other terms, B will be multiplied with the A is at the end, so A will come first, B and C will so there. So similarly here you can see, without saying, this will B square plus A square plus B square, and A placed there will be CB will come, because C is common for them. So here it will CB, it will be CA, C. So this will be a kind of you can say orientation when you do the matrix square. So the terms will behave like that. Okay. So this is the end of the session. In the next session, I will move on to the problem number 7 and onwards. So thank you for now.